Okay, so you ever get that feeling like when you're trying to hook up something behind your TV, right? And it's just a mess of wires and you have no idea what goes where?
Oh, yeah, all the time.
Or like when you're looking at your internet modem or something and
Yeah.
it's flashing all these lights and numbers, but they don't actually mean anything to you, you
No.
know? It feels like you need a decoder ring or something.
Right. Like, is it working? Is it not?
Well, that's kind of what we're talking about today.
Yeah.
A device that helps clear all that up. It's called an optical multimeter, or OMM.
Uh-huh.
And we're going to do a deep dive today based on this user guide we found for one of these things.
Cool.
Basically, it's all about understanding fiber optic and Ethernet cables and testing them and figuring out what's going on.
Yeah, making sense of the signals, right?
Right, exactly. So before you think this is like super technical, it's really not.
Hmm.
Anyone who's ever wondered, like, how does the internet actually work?
Like, how does my Wi-Fi even get to my computer?
Yeah. Or how does data, like, travel around the world? There's some really fascinating stuff in here.
Definitely.
So we're not going to just read the manual, I promise. We're going to take this OMM and we're going to break it down.
Yeah.
All the jargon, all the features.
Like what it actually does.
Exactly. So
Yeah.
you're going to walk away being like, oh, okay, I get it.
Yeah, I get how this stuff works.
Yeah. And maybe you'll even see how this technology is like already part of your life.
Yeah, exactly. It's all around us.
All right. So let's start with the buttons on this thing because it's got a lot of them.
Yeah, this one's got 8 buttons, and they actually, some of them do different things depending on how long you press them.
Oh, interesting.
Yeah, so button 1, if you just press it quickly, it turns on a flashlight.
Oh, that's handy.
Yeah, imagine you're like in a server room, right? It's dark, you're trying to find a specific cable.
Yeah, I can't see anything.
That little light is going to be your best friend. And then if you hold down button 1, that's how you turn the whole device off.
Okay, makes sense. Light on, light off.
Yeah, simple.
So button 2, also about light, but different kind of light, right?
Yeah, so a short press on button 2 adjusts the brightness of the screen.
Okay, so if it's super bright or super dark, you can adjust.
Exactly. But then a long press on button 2, this is where it gets cool, it turns on a red light mode. You might see it say like 1 hertz, 2 hertz flashing.
Red light, what's that about?
So that red light, that comes from something called the VFL, Visual Fault Locator.
Okay.
And basically it's like a tiny little laser pointer, but for fiber optic cables.
Okay.
So you can shine this red light into one end of the cable, and if the cable's good, you'll see the light come out the other end.
Oh, cool.
But if there's a break in the cable or a really sharp bend, that red light will escape at the point of the damage.
Oh, wow.
And you'll see it, like glowing red.
So like a visual way to see where the problem is.
Exactly. And those flashing modes, 1 hertz, 2 hertz, those just help you see that light easier if you're looking at a really long cable. Or it's in a messy area like, dusty attic or something.
Yeah. Right. Okay, so you can actually see what's going on inside a cable.
They're pretty cool, right?
That's really neat. Okay, button 3. Now, this seems to be where we get into the actual measurements.
Yeah.
So short press switches between these different modes. It says REF dBm plus dB and MW plus dBm.
Right.
Now, that's just a bunch of letters to me.
Yeah, I mean, it looks complicated, but it's basically just how we talk about the power of the light in a fiber optic cable.
Okay.
So dBm, that's a unit of measurement, and it's a logarithmic scale.
Logarithmic. That sounds complicated.
It sounds complicated, but it's just like a way to represent really big or really small numbers in a simpler way.
Okay.
Like think about the Richter scale for earthquakes, right?
Yeah.
It's like that. So like a reading of 0 dBm means there's 1 milliwatt of power.
Okay.
And then as the signal gets stronger, the dBm number goes up, but it's not a straight line.
Okay.
Now, REF, dBm, the REF, stands for reference, and that's just a starting point that you can set.
Okay, so you can say, like, this is my baseline.
Exactly. And then M plus dB just shows you the difference, like how much stronger or weaker the signal is compared to that reference point.
Okay.
So it's showing you the gain or loss. Then we have MW, which stands for milliwatts, and that's a simpler, more straightforward way to measure the power.
Okay, so like the raw power.
Yeah, exactly. And then dB is just that same power expressed in that logarithmic scale we talked about.
Okay, so dBm is like the standard way, and REF-dB is like setting your own starting point.
Yeah, exactly.
Okay. What about a long tress on button 3? What's that do?
A long press on button 3 is how you set that reference point, the REF DDM.
Oh, okay.
So let's say you're testing a fiber optic cable, right? You measure the power at one end, and that's your good signal.
Yeah.
You hold down button 3, the OMM saves that as your reference point. Then you go to the other end of the cable and take another measurement.
Okay.
And then by just quickly pressing button 3, you can see the difference, the gain or loss compared to your reference.
Okay, that makes sense.
Yeah.
So you can see how much the signal degrades over the length of the cable.
Exactly.
Yeah, that's pretty cool. All right, button 4 is all about network cables, the kind we all use for internet, right? Shirt press toggles the network cable test, and the guide mentions checking the network cable line sequence. What is that?
So inside a network cable, you have 8 tiny wires, right?
Right.
And they each carry signals in a specific order.
Okay.
So the network cable line sequence is basically just checking if those wires are connected in the right order at both ends of the cable.
Oh, okay.
So a short press on button 4, it sends a little signal through each wire to make sure it's connected to the right pin at the other end.
Okay.
And the OMM will show you a pattern of lights to tell you if they're all good. If one of the lights is off or it's in the wrong place, you know there's a problem with the cable.
So it's like a quick check to see if the cable's wired correctly.
Exactly.
Okay, got it. And then a long press on button 4 takes you to hunt mode. That sounds kind of cool.
That's that. All right, imagine you're in a room full of network cables, right? Like hundreds of them.
Yeah.
And you need to find the one that goes to a specific device.
Yeah, like finding a needle in a haystack.
Totally.
Okay.
So hunt mode, you need a little remote unit for this, and you plug it into the cable you're trying to find.
Okay.
And then your OMM, when it's in hunt mode, it can detect the signal from that remote.
Oh, cool.
So you just go around with your OMM, and when it gets close to the right cable, it'll beep or light up or something.
Wow, so you don't have to trace every single cable.
Exactly. Saves a ton of time.
That's awesome.
Wow.
Okay, button 5. This one's about saving and viewing data.
Yeah.
Short press takes you to a save data view mode. Long press saves the current power value. So when would you actually want to save readings?
This is all about record keeping. So let's say you're installing a new fiber optic network, right?
Okay.
You're taking power readings at different points to make sure everything's good.
Yeah.
You can save each reading with a timestamp and everything by long pressing button 5. Then later, you can go back and look at all your saved readings by short pressing button 5.
So you can generate a report or something.
Yeah, exactly. It's like a little logbook for your network.
That's super handy. And what about this threshold thing? The guide mentions that.
Oh, yeah, thresholds. That's a really cool feature.
What is a threshold in this context?
Okay, so a threshold is basically a limit that you set on the OMM.
Okay.
Let's say any signal that's weaker than negative 30 dBm is bad.
Yeah.
You can set that as your threshold. And then whenever you take a reading, the OMM will tell you if it's a pass or a fail.
Oh, cool.
So you don't have to look at the numbers every time and figure it out yourself.
Right. It's like a quick indicator.
Exactly. It just tells you if the signal is good enough or not.
Okay, so you can basically set it to alert you if something's wrong.
Yeah, exactly.
That's super useful. Okay, button 6 deals with wavelengths.
Right.
Short press switches between different wavelengths, like 1310 nanometers, 1550 nanometers. Why do those specific numbers matter?
Okay, so imagine different wavelengths as like different colors of light, right?
Okay, yeah.
And in fiber optics, different colors behave a little differently.
Okay.
Some are better for longer distances, some are used for specific types of equipment. 1310 and 1550, those are two of the most common wavelengths used in fiber optic networks.
Okay, so different wavelengths for different purposes.
Yeah, exactly. So when you're testing a fiber optic link, you need to make sure your OMM is set to the right wavelength to get an accurate measurement.
Got it. And a long press on button 6 is for wavelength ID mode.
Right.
What's that all about?
So some light sources have this special feature called 2WINS mode.
Okay.
And basically they can tell the OMM what wavelength they're using.
Oh, cool.
So if your light source has 2WINS mode, you can just hold down button 6 on the OMM and it'll automatically figure out the right wavelength.
Oh, that's convenient.
Yeah, it's pretty slick.
So you don't have to select it manually.
Exactly.
Okay, so we've covered the first 6 buttons, which are all about functions and stuff.
All right.
Now we get to the ports, which are buttons 7 and 8.
Uh-huh.
So button 7 is the OPM port. OPM stands for optical power meter.
Mm.
So I'm guessing that's where you plug in the fiber optic cable when you want to measure the power.
Yeah, that's exactly right. You got it.
Okay, and then button 8 has a bunch of different connections. A VFL port, an RJ45 port, and a Type-C port.
Right.
So VFL, we know that's for the visual fault locator, the red light. So you plug the red light source in there.
Uh-huh.
RJ45, that's the standard connector for Ethernet cables. So that's where you plug in for those continuity tests.
Yeah.
And then Type-C, that's got it for charging, right?
Yep. Type-C is for charging the OMM.
Okay, makes sense.
Some models might also use it for data transfer, like if you want to connect it to a computer or something.
Oh, right, to download the readings.
Exactly.
Okay, so we've gone through all the buttons and what they do.
Yeah.
Now let's look at how you'd actually use this thing in real life.
All right, cool.
So first scenario, you need to measure the power in a fiber optic cable.
Mm-hmm.
What are the steps?
All right, so first, you connect the cable to the OPM port, which is basically button 7.
Okay.
Then you do a short press on button 3 to switch to the milliwatt reading, the MW mode.
Okay.
That just gives you a straightforward measurement of the power.
Okay.
Now, to measure the signal loss, you're going to take a reading at one end of the cable and then long press button 3 to set that as your reference point, the REF dBm.
Gotcha.
Then you go to the other end of the cable, take another reading, and short press button 3 to see the difference.
Okay, so you're seeing how much the signal has weakened.
Exactly.
Okay, what about testing an Ethernet cable? How do you do that?
For Ethernet, you connect the cable to the RJ45 port, which is part of button 8.
Okay.
And then a short press on button 4 does that continuity test.
Right, to see if the wires are connected correctly.
Exactly. And remember, if you have a really long cable and you suspect a break, you can use the hunt mode with the remote unit to find it.
Okay, yeah, that's a good point. What about the red light, the VFL? When would you use that?
The red light. Okay, so you plug your red light source into the VFL port on button 8.
Okay.
And then a short press on button 2 turns on the light.
Okay.
Now, if you're trying to trace a cable or you're looking for a break, you can use the long press on button 2 to make the light flash.
Okay.
That can make it easier to see the light if it's escaping from a break in the cable.
Got it. And how would you save readings if you wanted to create a report later?
Easy. You just take your reading and then long press button 5 to save it.
Okay.
Later, you can short press button 5 to view all your saved readings.
Okay, that's pretty straightforward. So we've covered the basics.
Yeah.
Now the guide also mentions some more advanced features, like threshold alerts. How do you set those up?
Threshold alerts. Okay, to set those, you have to press buttons 3 and 4 together for a second or so.
Okay.
That takes you to the threshold setting mode.
Okay.
Then you can use buttons 3 and 4 to adjust the threshold value.
So you can set it to whatever level you want.
Yeah, exactly.
And then any reading above that threshold will be a pass. And any reading below will be a fail.
Right.
Okay. What about user calibration?
User calibration, that's a little more technical.
Okay.
Basically, it's a way to make sure the OMM is giving you accurate readings.
Okay.
You might need to do this if you've replaced a part in the OMM or if it's been a while since you last calibrated it.
Okay.
To enter calibration mode, you press buttons 3 and 6 together for a second.
Okay.
And then you use buttons 3 and 4 to adjust the calibration settings.
Okay.
And then a long press on button 5 saves the settings.
So it's a way to fine-tune the accuracy.
Exactly.
What if you need to reset the whole device?
Factory reset.
Yeah.
Easy. Just hold down buttons 1 and 2 together for a second.
Okay.
That wipes all your settings and puts everything back to the default.
Like a clean slate.
Exactly.
The guide also gives some troubleshooting tips. What if the display is really dim?
Dim display almost always means the batteries are low.
Okay, that makes sense.
Just replace them with fresh ones.
Okay. What if you're getting power readings that don't seem right?
Power readings off. Could be a dirty OPM port.
Oh.
Right? Even a little dust can block the light and mess up the readings.
Okay.
So make sure to clean the connector on the fiber optic cable and the port on the OMM.
All right, good tip. And what if the wavelength ID feature isn't working?
Wavelength ID. Remember, that only works if your light source has TWINS mode.
Oh, right.
So if it's not working, you probably just need to select the wavelength manually.
Okay, makes sense.
Okay.
Okay, so we've gone through a lot. Let's just quickly review some of these key terms to make sure everything's clear.
Okay, sounds good.
So dBm, that's our absolute power measurement. It tells us how strong the signal is.
Right.
And the closer to 0, the better, right?
Yep, the higher the dBm, the stronger the signal.
Okay, then REF dBm, that's the reference power level that we set as our starting point.
Exactly.
And we use that to measure the changes in the signal.
Right, like the before and after.
And then we have dB, which shows us the gain or loss compared to our reference. MW, milliwatts, that's just another way to measure the power.
Yep, a more straightforward unit.
Okay, then we talked about network cable line sequence, which is making sure all the wires in an Ethernet cable are connected correctly.
Right.
And hunt mode, which helps us find specific cables.
Like a cable detective.
Exactly.
And then there's OPM, which is the optical power meter.
Right.
VFL, the visual fault locator, which is the red light. Wavelength, which is the color of light used in fiber optics.
Okay.
TWINS mode, which is the automatic wavelength detection feature.
Right.
Threshold, which is a preset limit that we can use to get quick quick pass-fail results.
Right.
User calibration, which is how we fine-tune the accuracy of the OMM.
Yeah.
And factory reset, which puts everything back to the original settings.
All right, we covered it all. So the big takeaway here is that this OMM is a pretty versatile tool. It can do a lot of different things, right?
Definitely. It's not just for experts either.
Right.
Anyone who works with networks can benefit from using one of these.
So if you're just starting out, probably the best way to learn is to just start with those basic power measurements.
Yeah, just get a feel for how the readings work.
And then once you're comfortable with that, you can start exploring all the other features.
Exactly. There's a lot you can do with this thing.
So here's something to think about. Now that you know a little bit about how we diagnose network issues, what other technologies that you use every day might have similar diagnostic tools?
Ooh, that's a good question.
Like your car, for example.
Yeah, cars are full of sensors and computers these days.
Right, or your smartphone, or even your home appliances.
Yeah, it's amazing how much technology is hidden in plain sight.
Right, so there's probably a lot of cool stuff going on behind the scenes that we don't even realize.
Definitely.
So maybe this deep dive has sparked your curiosity a little bit. Even if you're never going to use an OMM yourself, it's kind of cool to know how this stuff works.
I think so too. It gives you a new appreciation for the complexity of our connected world.
Absolutely. Well, thanks for exploring the OMM with us. That's it for this deep dive.
Thanks for having me.
See you next time.